This conference will now be recorded.
Is my screen visible, madam?
Yeah, visible, Ram. I am in
Okay, good,
mobile.
good. Okay, okay. So fine. Actually, here in the preview, it is not showing. That's why. Okay, I'll just
Okay.
This conference will now be recorded.
yes. So Deepa, today we'll be deriving the kinematic equations of motion, and we'll see applications of these equations. So in the previous two classes, we had already learned what is position coordinate, what is frame of references, what is velocity, acceleration, average velocity, instantaneous velocity, etc. We have learned. Even we have even learned how to represent velocity in the graphical representation, velocity and acceleration in the with respect to time. So today we'll derive these kinematic equations in two ways. One is graphical method and another one is by calculus. So let us start with the graphical method. So you can see I have shown you here a figure. This is velocity time graph A, B, C, D. This graphs already I had discussed with positive acceleration, negative acceleration, and then uh, uniform accelerations, etc. I had discussed. So the beauty in this velocity time graph is that the area under the curve will give you the displacement of an object over a time interval. What it gives? It gives the area under the curve, BT curve, will give you the displacement of an object over a time interval. But that is true for only when your object is moving with a constant or uniform acceleration. Uniform acceleration in the sense acceleration does not change with time. So in our discussion, acceleration, see, in many complex situation, complex motion in practical life, acceleration may change, but in our study in this standard we'll learn motion with constant or average acceleration. So average acceleration or constant acceleration. So this is the condition when the VT curve will give you the displacement. Okay, so the area under the VT curve gives the displacement. Now the kinematic equations which we are going to derive today are these. The first one is V is equal to V0 plus AT. So where V0 is initial velocity, that means suppose at t is equal to 0, the velocity of the object is V0. Okay, and V, this V is actually the final velocity after certain time interval. Okay, after certain time interval, suppose at time t is equal to t. Okay, so if you know the initial velocity and the acceleration, average acceleration with which the object is moving. If you know these two terms, initial velocity and average acceleration, then you can find the final velocity of an object after certain time interval. Okay, so this first equation is saying that this is actually, you can say, you can just give a heading like this. So this actually velocity after certain time interval, velocity after certain time, after certain time. And the second equation is the displacement is, actually I am denoting here is, or we can denote this by x also. I think I have mixed up the notation. I'll just write it as x. Okay, x is the displacement of the object after certain time interval t. Okay, if I, when I'm saying time interval, then t2 minus t1, this is the time interval where t1 I have taken as 0 and t2 I have taken as t. Okay, t2 I have taken as t and t1 is 0, so time interval will be t only. Okay, now what does this x second equation signify? This signifies that if you know initial velocity and the average acceleration, you will be able to find out the displacement of the object at any, after any time interval t. Okay, this is what the second equation of motion is inferring. Okay, now see, this is third and this is fourth equation. Generally these three equations are important for any, for analyzing any kind of motion. These three equations are being used throughout our discussion. We will be seeing that. So look here, actually v0, as I said, this is have carrying the same meaning, initial velocity at t is equal to 0, and v is also carrying the same meaning, velocity at any instant of time, okay, after any interval of time. And in this case you look, this is final velocity, this is initial velocity, this is acceleration, this is displacement. So this equation actually connect the final velocity, initial velocity and acceleration with the displacement of an object. That means if you know the displacement, how much displacement happened during the course of motion, and if you know the acceleration with which the object was moving, and if you know the uniform initial velocity, which is v0, if you know these three parameters, then you can easily find out the final velocity of the object. Similarly, this equation actually is very important when we talk about vertical motion and how much maximum height rises and all those things. We'll be discussing in the due course of our discussion. See, this equation can be used for calculating maximum height, also maximum distance, maximum height, etc. Okay, now the last one is, actually this is important, and sometime there will be numerical problem in your competitive exam, or maybe the derivation also may be asked in board exam. So this is actually the displacement of an object at any instant, actually nth second, at nth second, suppose nth second, at nth second. So this is telling you that if you know the initial velocity if you know the acceleration of the object, then you can find out, suppose in fast, so so you may be asked, in 10th second, what will be the displacement? In 10th second, what will be the displacement? In 100th second, what will be the displacement? So you have to use this fourth equation to find out that. Okay. Okay, so then let us start deriving these equations first, then we'll try to understand the various applications of these equations. So first we'll derive this equations of motion by graphical method. Look, the first equation we have taken is this one. The final velocity excuse me, the final velocity v, final velocity means the velocity after some time t. So I'll just tell you one thing. Suppose in this, see, while deriving these equations, what I have supposed that an object starts moving from this origin. Okay. Oh, sorry, just a minute. Yeah, so suppose the object starts moving from origin along the x direction. Since it is one-dimensional motion, I have taken a single axis of coordinate as reference frame. Now suppose I start seeing the object or observing the object after traveling up to this point. Suppose here the object starts with velocity v is equal to 0, but I'm seeing this portion only. I'm just observing the motion of the object during this time interval at t is equal to 0, suppose. So when I start observing the object, I have set my uh, watch at t is equal to 0, suppose. Okay, stopwatch. And at that particular instant of time, suppose t is equal to 0, the object has already v0 velocity. This is called initial velocity. And suppose the initial displacement from the origin, it is actually s0, or you can just take x0 also. And after time interval t, okay, after t seconds, the object gains a velocity v. This is the final velocity which is attained after time t. And by that time, the object has attained the displacement of s, which you can write even x also. Now the final velocity is given by this equation. This we have already learned that this is velocity after certain time. This is the expression v is equal to v0 plus at, where a is the uniform acceleration or average acceleration of the object. Okay. Now look how to derive this equation from the graphical concept. Okay. So look here, I'll just come from the definition of the average acceleration. We know from the definition of average acceleration that average acceleration a average is equal to final velocity minus initial velocity, or we know, like, see, average acceleration means v2 minus v1 divided by t2 minus t1. This is what we know. So here v2 is your v and v1 is v0 and t2 is t and t1 is 0. So this is what has been written over here. And look, from here what we get is this average is going to v minus v0 divided by t, and from here you can find out what is the final velocity a. So v0 plus a average into t. since the average acceleration is constant, and this is the acceleration with which the object will be always moving, and we will be treating all the cases with average acceleration or constant acceleration. So a bar can be written invariably as a, so you get this as at. So this is your final velocity, you get it from here. Okay, so now if I just show you graphically, see, graphically I'm showing you that the object, in this case here, the object starts from origin at t is equal to 0 here, at t is equal to t at d. Okay, object is at d. Now when the object was at t is equal to 0 at the origin, that time the velocity was here v0, and during this time interval 0 to t, that means interval t, in this, during this interval the object has moved up to v, actually gained velocity up to v. This is the velocity v. Okay, now in this curve, see what is the, like, how do you represent actually this particular velocity, final velocity is represented by this AB straight line, this AB straight line. So how is it so? Suppose this is V, we know, like, see, you might be learning the equation of a straight line, y is equal to mx plus c. Mx plus c, m is the slope, x is the intercept, and c, sorry, c is the intercept and x is the coordinate. In this is the independent coordinate, x here it is t. So if I write v is equal to m, means m means the slope of this curve. Slope, since this is a straight line curve and it is having a tendency to go through the origin. If I just shift my origin over here, so it is going through the origin, so I can take the slope as y by x, or v minus v0 by, this is y by x is t. This is how we can write. So mx plus c, look what we can write, m into x we have written already. So m means v minus v0 by t, mx, x is also t at certain instant of time. What is c? C is actually your this part, this initial velocity v0, this is c, intercept is that one. Okay, so you can write this v minus v0 by t, this I have already told you, this is average acceleration, so I can write that as a, so this as a, so this part as a, this particular part in the bracket I can write as a. So you can find, see, the final velocity is v0 plus a into t. Okay, a is the slope here, which is actually in the velocity time curve. You might be remembering that in the velocity time curve, the slope actually gives the average. The slope of the line, slope of the straight line joining between 2 points will give you the average acceleration. So that's why I have taken this as average acceleration. Okay, if there is a problem, I'll just repeat quickly. So I'll just come from my mathematics knowledge, see, or geometry knowledge. See, I know v is equal to mx plus c. M means what? M is the slope of this AB curve. What is the slope of AB curve? This is actually v minus v0, y by x. Since it is a straight line, I can write this y by x. Y is this v minus v0, this part, and x is the time t, interval t. Sorry, this is t and y by x. So x is this, and again this mx plus C means the intercept, that is V0 over here. So X is actually T here. So I'll just remove this X. I'll write as T over here. Now look, this term I am just terming as average acceleration into T plus V0. Okay, so this is how we can derive this equation, final velocity, equation of final velocity, or the velocity after certain time T. If you know the average acceleration of the object with which the object was moving, and if you know the initial velocity of the object, you can find out easily the final velocity of the object. Okay, so now we'll just try to derive the second equation from this curve itself. So second equation, if you remember, see, the second equation was S is equal to, or I'll write here, the second equation is this one. Okay, the second equation is this one. It is related to the initial final velocity. So displacement after certain time, x is equal to u0 v0 t plus half into a t square. This is the one. Okay, now see, again we know from the knowledge of our graph that velocity time graph, area under this velocity time graph will give you the displacement. I'll just come from there. So then what is the area under this curve here? So in this time interval 0 to t, so what is the area under this curve? This is a trapezium. You can do in that way also, or else you can just find out the area under this OA CDO, this rectangle, and the area of this triangle ABC, just by putting half base into height. So this is what has been done here. See, the displacement during this time interval for the object here is, see, the area under this curve plus area under this triangle. So half base is t, and height is b minus b0. So this is the displacement. So this I have got from the graph. Now let us see what we can do with this. We know, if we just let us do one thing. Let us just do some simplification with this itself. So, or else we'll just do one thing here. We have learned from this past equation that v minus v0 will be at. So if we just put it there, we'll directly get that. So v0 into t I'll keep as it is. Then half, what is v minus v0 from here? V minus v0 is equal to this, see, from this equation, v minus v0 is equal to a into t. So I'll just put it here, a t, and you had already 1t here. So what you get is this. So v0 t plus half a t square. Okay, this is how you can derive the equation, second equation of motion. This is second equation of motion. Ut sometime v0 initial velocity is written as u also. So v0 t plus half a t square. Okay, v0 t plus half a t square is the displacement of any object at any instant of time t if the initial velocity is v0 and average acceleration is a. This is, so what we have done here, we have just found out the expression for the area, under this curve a b c d o a, this curve. Okay, so area under this curve will be, see, area of this rectangular part and area of this triangular part. So this is what has been written over here. Now we just put this v minus v0 as a into t. So what we get is v0 into t plus half a t square. Okay, so this is how what we get. We get to derive this x is equal to v0 t plus half a t square. Okay, this is second equation. Now let us derive the third equation, which is relating the displacement with the initial and final velocity. So this is actually v square is equal to v0 square plus 2ax. This is the fourth equation, third equation. Let us see how we can derive that. So see, from here we can just directly come from there. So we can just write this. Okay, so we have seen that x average. So from here also we can find out that the x average, the displacement for an object which is moving with uniform velocity v bar or average velocity, the displacement after certain time t will be v0 into t. V bar into t. This is bar is the average velocity. So average velocity is given by this equation v plus v0 by 2. Okay. Now so I'll just put it this in this equation itself. So this average v average is v plus v0 by t into t. This is the v average into t. Now I'll just write again that expression for t from here. T is actually v minus v0 divided by v minus v0 divided by a. Okay, this is the time over here. So if I just multiply here, so v plus v0 by 2 into the time is actually v minus v0 by a. So this is the expression. So now if we just multiply both, say look, this half will come here, or I'll just keep it denominator. It will be v square minus v0 square, because a square minus b square formula, and this is by 2a. So if we just simplify a bit this thing, I'll just strike this. So what we get is x is equal to v square minus v0 square divided by 2 into a, or if we rearrange this, we will get v square is equal to v0 square plus 2ax. This is the third equation. Okay. Now what we'll do, we'll just find out the special equation. Suppose displacement is denoted by s is equal to ut, or I'll write v0t itself, v0t plus half of a, half into a t square. Obviously this a, depending on a, the sign will be changing over here. If it is minus acceleration, then it will be minus here. If the acceleration is positive, that's why it is positive here. Okay, so using this equation, we will be finding out Sn, that means displacement at nth second. So let us do one thing. I have drawn this schematic diagram. Suppose the object is moving till n seconds, or I am just observing the object is moving. I am observing the object 0 to n second. Okay, or n second, and the displacement is this one. So this displacement supposition, and now look this one, this interval, suppose this is actually the displacement by at time n minus 1. Okay, during this interval 0 to n minus 1 second. So this, suppose this is Sn minus 1. I'll just put n in place of t. Okay, here. So I'll just write two equations. One is Sn, which is v0 n plus a half a n square. Okay, half a n square. Now let us see what is the displacement during this time interval 0 to n minus 1. So it will be v0 n minus 1 into half a n minus 1 whole square. Okay, if we just simplify a bit here, so this I think I'll just write everything v0 n minus v0 plus this along with this term n square minus 2n plus 1. Okay, if we just see, if I just take difference between this n minus of Sn minus 1, that means the displacement during the time interval 0 to n, and this is the displacement of the object during the time interval 0 to n minus 1. I'll just take simple example. Suppose n is equal to 10. Okay, and see n minus 1 will be 9th. So you have to find out this displacement at 9th second. Then what you do? These are the intervals. This is not the instant. So you just take the displacement value at s is equal to during this interval 0 to 10 and get the displacement of the object during the time interval 0 to n, and then take the difference as I am taking here. This will give you the displacement which is traveled at nth second. Okay, then you will get the displacement of the object at nth second. So this, if you just simplify, you will get a nice expression for this Sn. For the time being, I'll just write here and I'll leave on you to derive this expression and see how you get. So there will be numerical problem from this particular equation. It is actually, see, finally, so what I'll write, so Sn is equal to Sn minus Sn minus of 1, and if you just simplify those two, what you are supposed to get is v0 plus a by 2 into 2n minus 1, 2n minus 1. So this will give you the distance traveled in nth second. Distance in or displacement happened in nth second. Nth second. Okay, this is the expression. You have to derive it, and you better you remember this, because in your competitive exam there will be some questions from this particular expression. Now I'll just go to another new topic. Sorry, not new topic. This is actually the derivation of the same equations of motion if I do by calculus. How we can do this? So I'm just deriving the same equations of motion. That means my equations of motions I'll just write over here once again. Final velocity is v0 plus a into t is the average acceleration, t is the interval of time here, and then x is ut plus half a t square, and then third equation is the final velocity square is equal to initial velocity square. Okay, u and v, I'm just mixing up, so I'll just remove this v0. I'm just denoting again u, because I am very much accustomed to use initial velocity as u. Please forgive me. You just, this is initial velocity. Initial velocity. Okay. So this is this. Okay. We'll try to derive using calculus. So when we are going to use calculus, we'll just see first the definition of acceleration. So definition of acceleration is dv dt. Okay, dv dt. Now see, I'm just going to derive this first equation. So what I have to do, what best I can do is this one, dv is equal to a into dt. If you know the calculus, it is very good. Otherwise you have to learn it now itself without waiting for promoting to 12th grade and learn. Now itself you should learn. Now you just take the integration of this quantity left hand side within the velocity, u to v. Okay, initial velocity to final velocity, and this acceleration, you can, because it is constant or average acceleration does not change with time, I'll just keep that in out of integration with respect to time, and here I'm just taking t 0 to t limit and dt. So you look here, we will get v square, sorry, v is equal to v minus u is equal to a into t. This is what we will get, and finally you will get v is equal to u plus at. Okay, u plus at. So this is how by calculus, see, coming from the definition of acceleration, I can come up to this expression v is equal to u plus at, or final velocity is equal to initial velocity plus acceleration times acceleration into time interval. Okay, we have derived the first equation, let us derive the second equation, which is x is equal to, so look here, from this expression itself we will go. So we have got acceleration is equal to dv dt. Okay, now this dv dt, we have to write this dv dt, we have to bring actually x. So what we have to do is actually see d dt of dx dt. Okay, this is the expression for acceleration. All right, so better what we'll do, we'll start from the velocity expression for the velocity, not from acceleration. This is not the correct way to do. We'll just come from expression for the velocity. We know velocity expression for the velocity is dx dt. Now what we'll do, we'll just integrate it, dx is equal to v into dt, and this v can be replaced by v or u, initial velocity, plus a into t dt. Okay, okay, I think it is very messy over here. I'll just clean everything and then I'll just repeat the calculation part. Just wait for a minute. This too messy over here. This, see, I'll come from, so second equation I'm going to derive. I'll come from the definition of velocity. So this is dx dt. Now what I have to do is I have to do the integration part. So dx, integrate it, and this is actually from x0 to suppose x, and this is v into dt. In this case, you have to think that whether this v is a constant or it is changing, because it is uniformly accelerated object, so v cannot be a constant quantity. So we have to replace this v by u plus at, this expression. We have to replace by this expression u plus at and dt. Okay, this integration, this time 0 to t. Okay, so if you just simplify this, what you get in the left hand side is x minus x0 is equal to ut here plus half a t square. Okay, so you can write again this in terms of x0 plus ut half a t square. Okay, so this is how you can derive from calculus the second equation. What is this x0? X0 is the initial displacement, suppose. Okay, and let us see how to derive the last equation. The last equation is, or the third equation of motion is, v square is equal to u square plus 2ax. This is what we have to derive here. So here to derive this one, I'll just come from acceleration, equation of acceleration. This is again dv by dt, or you can write this as dv dx, integration dx by dt. Okay, kind of, just to remember, you just strike them out, you'll get dv dt. Okay, so this is how we can write. So if this is the case, so dx dt is another velocity, so I'll write in terms of velocity v, and this is dv by dx. Now I have to find out this velocity, so I have to integrate it. So v dv, integrating u to final velocity v, and this is a into dx. Acceleration is not changing with time or space, so this can be written outside also, and this has to be taken 0. So acceleration x0 to x, sorry, this is displacement. So displacement x is going from x0 initial displacement to some final displacement x. So if I just integrate it, see what I get is actually v square minus u square is equal to, this is 2 obviously, so this is equal to a into x. So from here what implies is this, v square is equal to u square plus 2ax. Okay, so this is how we can derive this, obviously this is not x, it is actually x minus x0, since we have taken initial displacement x0 at time t is equal to 0. So with this, uh, the derivation part is over for the various kinematic equations. So what we have learned here, we have learned 3 kinematic equations. So one is final velocity v is equal to u plus at initial plus this, initial velocity plus this. Then second equation we have learned related to displacement, x is equal to ut plus half a t square. This u and v0 don't get confused. So u is the initial velocity, v0 also initial velocity. So the third one is the final v square is equal to initial v square plus 2ax. Okay, this, or this is x minus x0. Okay, these are the equations. These are called equation of kinematics, or sometimes these are called equation of motion. Okay, now we'll see how we can apply these kinematic equations for vertical motion or freely falling particle. Okay, so what is free falling particle? Actually, free falling particle means, you have earth surface over here. So if any object is just released from very near to the surface, so at a height, this height is, suppose h, much less than its radius. So if an object is just released from a, a certain height h, which is very near to the surface, the object, as you can see from here, this is h, this is the earth surface. Suppose the object will actually, just after releasing, there is no there is no air resistance, if there is no resistance against the motion of the object, against the motion of the object, as soon as you release it, it will try to come down with an acceleration. This object will come down. It is, see, you can see this, it is coming to the earth surface, it is coming down with a certain acceleration, which is the acceleration due to gravity. That's why it is denoted by g, small g. So the object, since we have not applied any force on this object, this is free falling case. That means the object will be freely falling towards the ground with an acceleration, which is the acceleration due to gravity, and it is denoted by small g, and it has value 9.8 meter per second square. Sometime in your competitive exam, for the sake of calculation purpose or easy calculation, g will be given or mentioned to take 10 meter per second square. Okay, so this is, so the object which is moving under the influence of gravity is called motion under gravity. So if the object is moving under the influence of gravitational acceleration or the acceleration due to gravity, then we say the motion as motion under gravity. So I hope you have understood what is motion under gravity. If we release an object to freely fall onto the ground, then it will come down with an acceleration to the ground, and that acceleration is due to the gravitational force. That's why it is called acceleration due to gravity, and it is denoted by small g. It has value 9.8 meter per second, or sometime it will be given in your problem 10 meter per second square also. Okay, so this is called free fall. Free fall means there is no force acting there, neither you are applying any external force on the object, nor there is any resistance like air resistance, etc. Okay, so I'll just take up this example. This is from your book itself. A ball is thrown vertically upwards with a velocity v. Okay, so before I do this numerical problem, let me tell you how do we write the equations of motion under gravity. Equations of motion of an object. Equations of motion of an object under gravity. Object under gravity. See, under gravity means acceleration will be changed. That's all. Acceleration is g now. But here you have to understand that acceleration due to gravity always acts vertically downward. Always acts vertically downward. Whether you move downward direction or upward direction, that doesn't matter. But g, gravitational force or gravitational acceleration due to gravity always acts in the downward direction. Okay. And since it is moving in the downward direction, if my motion or the object under study is moving in the downward direction with certain acceleration a, then the acceleration of this object will be added up with this g. If it is moving towards the ground, that means both the acceleration, external acceleration and the acceleration due to gravity, both are in the same direction. Okay, so suppose we are just releasing an object of mass m at this point a, which is at height h, and this is hitting the ground. Just before it hits the ground, the time interval, total time elapsed is actually t. Then how do I write equation of motion? The final velocity will be u. You have to write u plus g into t. Instead of a into t, you have to write this. Okay. The second equation, v square is equal to u square plus 2ax if the object is moving towards the ground. So this is freely falling body. Okay. And what is the displacement? Displacement will be ut, so ut plus half a square. So in place of a, we'll be just writing g and with a positive sign. If the object is moving in the upward direction, then g is in this direction. So, and your acceleration is in this direction. So the resultant acceleration will be a minus g. That's why the object will be moving upward direction. So in that case, when the object is moving upward direction, what will be the equation of motion in the opposite case? So it will be final velocity. As you throw an object to a height, you will see the object will go with increasing velocity, and then after certain time it will just lose its whole velocity and comes to rest, and then it will again try to fall under gravity. Okay, so final velocity will be written as this. V square can be written as u square minus 2 gh, and displacement is given by s, which we can write ut minus a half a t square. If the object is moving upward, my sign of the gravity will be minus. So your g is downward, but your motion of the object is upward. That's why g has to be taken as negative. Okay. I think I'll stop it here because if I start this uh, example, it will take another 15 minutes maybe. So I'll stop it here just by writing these equations of motion for vertical, like motion under gravity. But that day, I think on the next class on Thursday, I'll just take an elaborate uh, class on the vertical motion of any object. Vertical motion of an object. Vertical motion of an object is very important and very much exciting because there the acceleration due to gravity always acts downward, and your motion can be sometime downward, it can be sometime upward. So accordingly you have to change your g. Okay, you have to change the acceleration, the sign of the acceleration. Okay. Okay, so thank you, Deepa. Thank you for your patience. If you have any doubt or questions, or if you want any clarification, you can ask me now. It is free, like you can feel free to ask me any questions on this topic what we have discussed today. Do you have any question, Deepa?
No, sir.
I did not get your response properly. Can you just tell me whether yes or no? If you have any question, you can write in the chat box because your sound is not very much clear. Okay, so I got a response that you have understood. You don't have any question. Then I'll stop it here. So bye for today. Thank you, Deepa. Bye for today.